Where's Kafil?
I don't know. He always late.
Hi guys! Hi guys! Sorry.
Kafil.
Sorry for being late. I just came back from hardware store with my uncle. And we buy some stuff, which is we buy rope
Wow.
not mine lah, for his new towing truck.
Oh, that's amazing. No wonder you guys always being late.
Sorry, I'm sorry.
Since you are here, do you mind I'm asking you some question?
What is it?
What are your uncle doing with the rope?
What kind of question is that? Obviously, he using it for towing cars.
Oh, sorry, bro.
So, we just bought the rope from the store and we don't know if the tension from the rope is enough to lift up the car with 1,200 kg from the road.
I know the way how to calculate this question. Let's go. So, Newton's law of motion, particularly the second law that can be used to analyze the motion of an object of an inclined plane without friction. There is several steps to understand the law through this scenario. Newton's second law states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. F equal to m times e. Since the plane is frictionless, the only force causing the object to accelerate down the plane is the component of gravitational force parallel to the inclined plane. So, to explain another detail about the situation, let's consider an object of mass m on an inclined plane with an angle theta with respect to the horizontal. The force acting on object are gravitational force Fg. This force acts downward towards the center of the earth. F times g equal to m times g, where g is the acceleration due to gravity. That means g is equal 9.8 m over s power of 2. Normal force that we call N, this force acts perpendicular to the surface of the inclined plane. Since there is no friction, it only has a vertical component that balances the component of gravity perpendicular to the inclined plane.
Alright, so moving on. To analyze the motion, we resolve the gravitational force into two components, which is parallel to the inclined plane, which is F parallel equal to mg sin theta, and the second one is perpendicular to the inclined plane. So F perpendicular equal to mg cos theta. Alright, moving on. Next, applying Newton's second law. Since the plane is frictionless, the only force causing the object to accelerate down the plane is the component of the gravitational force, which is parallel to inclined plane. Using Newton's second law in the direction parallel to the plane. So, F parallel equal to MA, we substitute F parallel equal to mg sin theta equals to MA. So we solve for A, acceleration, and then we divide M for both sides, and we will get A equal to g sin theta.
Okay, now we proceed with the problem statement. From the situation before, we can illustrate the situation as this figure, and now we need to calculate the tension in the rope and what does the plane, which is the road, exert on the cars. From the figure above, we now have the information about the situation, which is the mass of car m, the degree of inclined plane, which is the distance of the car lifted from the road, theta, and we add the gravitational force as g.
So, we want to find the value of tension in the rope and force does the plane exert on the car. First, since the system at rest, which is summation of F equals to 0, we need to resolving the force, which is summation of Fx equals to 0. We know that formula of summation of Fx equals to T minus mg sin theta equals to 0. From this equation, we can get a new equation for tension, which is T equals to mg sin theta. And we need to substitute the value of m, which is mass, g, which is gravity, and theta. So we got application which is 1200 kilogram mass, which is the mass of cars, and 9.8, which is the value of gravity, and sin 25. So we got the answer which is 4969.99 Newton. Next, we want to find the force that the plane exerts on the car. We know that summation of y also equals to 0, and the formula of summation of Fy equals to R minus mv cos theta equals to 0. From this equation, we can get a new equation which is R equals to mv cos theta. And we also need to substitute the value of m, g, and cos theta into this equation, which is 1200 kilogram of mass, 9.8 gravity, and cos 25. So we got the answer for this question, which is 10,658.18 Newton. That's the answer of our problem statement.
Right, in conclusion, we have observed how Newton's law applied to a car on an inclined plane where friction is absent. These laws are fundamental to real-life applications, allowing us to compute variables like the tension in the rope and understand the forces exerted by the road on the cars. This understanding not only clarifies the dynamics of such scenarios, but also demonstrates the practical utility of Newton's law in analyzing and predicting motion in everyday situations.